Krazifizix Maths and Science Made Easy. Krazifizix Maths and Science Made June 2026.
Hello everybody, this is Krazifizix bringing you the May-June 2026 solution for paper 2, easy. Now we've been looking at all the questions one by one in each separate video, and I'm your host, Bishop, making math and science very easy. Okay, let's get into organic reactions quickly. Now for organic reactions, we have an acronym. If you see this anywhere, know that it's a product of Krazifizix. If I were to quickly do a quick review here, let's see if we can do that quickly. So we usually say that I am single and I'm seriously searching. Then I went to the United States of America, where I married my girlfriend, and I call her Sue Baby. All right. So saturated is a substitution reaction, and unsaturated that leads to a saturated will be an addition reaction. A saturated that gives birth to an unsaturated as a product becomes an elimination reaction. Now, there's so much chemistry between us, so instead of saying Bishop wets Sue, we said chemistry said Sue for wets. Now, whenever I use a concentrated strong either acid or base, I am actually going to be eliminating. When I use a dilute strong base, I would actually be substituting. And for elimination, I need what you call strong heat because I am eliminating. And for dilute, I am going to need mild what? Heat. Conclusively, we then have a list of catalyst reactions. And once you know all of this, you are just easy to go. So if I want to look at my catalyst, let's quickly use a table and say reaction and catalyst. Just talk about 6 of them. Number 1, if I talk about hydrogenation, then my catalyst, I can simply use platinum or nickel. Platinum looks, very, very easy to remember. Number 2, if I'm talking about halogenation, I'll say UV light, which is basically your sunlight. Ultraviolet light. Number 3, if I'm looking at hydration means to add water. And here, I'm looking at alkenes being converted into alcohol. To hydrate means to have water, add water. So I'll say I'll have excess water. And I can use dilute sulfuric acid. Remember, if I use concentrated, I would be eliminating. I can also use phosphoric acid. Phosphoric acid is a weak acid. All right. So either I use dilute sulfuric acid or I use phosphoric acid. Number 4, if I look at hydrohalogenation, all right, here there shouldn't be any water at all. So no water, because if I then have water, I'll be actually producing alcohols. And number 5, if I'm talking about esterification, then I need to use concentrated sulfuric acid. And because it's elimination, I need heat. But that heat will be coming in the form of a water bath. And basically that is it. And if I have my combustion reaction, then I should be requiring excess oxygen. And this, I promise you, will answer any question we're about to see. All I need to know is now to apply my Markovnikov and Zaitsev. And that is a trademark of Krazifizix. Lovely. Let's go check. Study the flow diagram below. Compound A, B, C, D, and E are organic compounds. All right. So if I look at this, what is it? that I can really say. All right, the only thing I know here is I see bromobutane. Because it's a butane, it's a saturated compound. I didn't say hydrocarbon, it's just saturated. Lovely. And you can, if you look at reaction 1, I want us to see, do you notice that we are actually adding bromine to something to form chlorobutane? All right, so I could actually say that is butane. All right, that would be butane. We'll see if it's going to pan out shortly. And butane is saturated. Oh, so this reaction becomes what? A substitution reaction. Saturated to saturated substitution. All right, we know nothing about reaction 2 and the rest. We're going to really have to depend on the question. All right. With the total, reaction 6 is an addition reaction to form, if it's an addition reaction, then I can actually guess what this is. Now, that is butane, reaction A. It means the opposite would be an elimination. I can tell you that this is butene from A. So that becomes, because this is addition, addition will only occur from unsaturated to saturated. So basically, I am adding hydrogen. Oh, that really helps us to deal with the rest. Look at reaction 4. Reaction 4, we have saturated to unsaturated. We are eliminating. And because there's a bromine here, we'd need to remove the bromine. So it's minus HBr, dehydrohalogenation. Beautiful. Okay, what else? We don't have any information about 2, 3, and 5. Okay, let's go ahead. Write down the type of reaction represented with 1. Do you notice we are done? Number 1 is substitution. Number 2, reaction condition for reaction 1. Do you notice we are actually substituting? So what should we then be saying? What is the reaction condition? If I'm moving from saturated to saturated, I am adding bromine. So that should be halogenation. Let's see. UV light. I hope that is making sense with everyone. UV light. Okay, let's go to 4.2. Also, this is 4.1. Now, 4.2. In reaction 3, compound C reacts with what? That is, we don't know compound C, but we're going to get there shortly. This is a carboxylic acid. All right, so this is plus carboxylic acid. Interesting. Now they start giving us information. In the presence of concentrated sulfuric acid, react with a carboxylic acid in the presence of, that's interesting. So we know that we're trying to look for an ester here. All right. Therefore, write down. So once I see this, we talk about ACE. Alcohols will react with what? Carboxylic acid to form esters and water. So C, therefore, is an alcohol. Now check. Alcohol is also a saturated compound. So from saturated to saturated, it is a substitution reaction. All right. So 1-bromobutane. Let's quickly draw 4.2.1. We now need an alcohol. Check. Look, if I have 1-bromobutane, 1-bromobutane would have simply looked like this. All right. No, Br there. This is 1-bromobutane. But basically, do you notice what we're doing? We have now said compound C is an alcohol. So what will the structure then look like? Basically, we are removing that bromine and throwing in an alcohol. But I want to show you For that to happen, I would actually be reacting this with dilute sodium hydroxide. I want to show you how we get to C. It has to be dilute because it's substitution. So what's going to happen? This guy will take the place of this guy. Oh, so compound C therefore becomes 1, 2, 3, 4, and we have what? OH. And we are done. That's the structural formula. So you see, everything I told you there simply works out. Saturated to saturated substitution, and I made a dilute strong base. Done. Okay. Type of reaction represented by reaction 3. We already spoke about that. That is esterification. We can also call it elimination, all right? But esterification. The IUPAC name of D. Now, let's quickly answer the IUPAC name of D. We are actually taking what? 1, 2, 3, 4 butanol and reacting it with that. So we have butanol. Now, that only contains one there. So that is methanoic acid. And when these two react, they form an ester, and that is, we start from the alcohol side, which is butyl methanoate. Always start from the alcohol, all right, alcohol side. And that is it. All right, let's move together. I hope we are making progress together. Write down two terms for the type of reaction represented by reaction 2. All right, write down 2 terms for the type of reaction. So we're talking about the terms. What is it that is needed? What is it that is needed for the reaction? 2 terms. Or what type of reaction do we have? Now, if you look at reaction 2, it is both a substitution reaction and a hydrolysis, because we are using sodium hydroxide or water. 4.3. So it is both a substitution reaction, because we are substituting, and we can also call it a hydrolysis, because hydrolysis is actually a reaction with water. And you must quickly understand hydrolysis is a substitution reaction. Beautiful. Lovely. All right, 4.4. Compound C can be converted back to B. Let's quickly look at compound C. What is our compound C? Our compound CO is the alcohol, and our compound B is 1-bromobutane. If you really don't know what to do, this is what I'm going to ask you to do. So our C is the alcohol, which is, all right, there are 4 carbons there. Okay. But we want to break it down and convert it back to this. You've got to be smart with chemistry now. Check. I want this to come back. It means I need something that can react with this. Basically, it must have a Br. So I can actually use hydrobromic acid. What do you notice? This guy can take the place of that guy, all right? And Br can actually take the place of that, and I'll be forming water there. Can you see that? Again, it is a substitution reaction. So write down the formula or the name. I could simply say HBr. Let's put our answer there, 4.4. And what's the name of this? It's hydrobromic acid. So that we have a carrier for the bromine, 4.5. That's what you need, a bromine carrier. Compound B and C can be converted to E. All right, B and C can be converted. Okay, remember we have our B and C. Write down 1 term for the type of organic reaction for both 4 and 5. I think we answered that. We are looking compound B and C can be converted to E. Oh, lovely. Do you notice that saturated, because they told us compound 6. How did we get to this? It's an addition reaction. It means reversing it would be what? An elimination reaction. So addition reaction, eliminate. So that gave us an unsaturated. Oh, makes sense. Saturated to unsaturated, elimination. Saturated to unsaturated, elimination. Do you see that? It's working for us. So we are done with that. They said, what type of reaction is that? That is elimination. Please go back to that little summary that I did, understand it, and it will just help you. 5.2. Besides heat, write down a condition for reaction number 4. All right, for 4.5.2, let's go check. For reaction 4, ooh, look at what I wrote there. Because it's an elimination reaction, besides heat, if you go back, I did mention it, elimination, besides heat, we need concentrated what? Base. We're done. So an example of a concentrated base, reaction for that would be a concentrated base. You have to be very specific. Sodium hydroxide, strong base, or potassium what? Hydroxide. Those are the common ones that we use. Okay. For reaction 5, let's see quickly. What is reaction 5? Let's go back to reaction 5. All right, so we have an alcohol that we need to bring in back to that. We can simply use concentrated sulfuric acid. If you come back here again, elimination, concentrated strong acid or base. And what is my base? Sulfuric what? Acid. We are done. 4.5.3. Concentrate. Please mention the fact that it has to be concentrated. Once I see concentrated, I know it has to be an elimination. Consider reaction 4. Use structural formula. Write down the balanced reaction. All right, let's go do this. I love reaction 4. So we have 1 bromobutane and we are taking it back to an unsaturated compound. All right, 1 bromobutane. We're going to explain the chemistry here. 1 bromobutane. 1, 2, 3, 4 Br. Okay, and it is elimination. Remember, if it's elimination, I'll have to use a concentrated, let's use sodium hydroxide. All right, sodium hydroxide. What are we then going to have? Look at what we're going to have. So quickly, I see that we have to remove. And if I'm removing, I'll have to remove this because it's concentrated. And I'll look at, okay, this one is very straightforward because it's at the extreme. This hydrogen needs to go. All right. Otherwise, if the bromine was in the middle, I'll have to find a carbon that has the least hydrogen, ZF. Okay. But in this case, it's very straightforward. Look at what I'm going to have. There we go. Now, those two are gone. And that automatically gives me a double bond because carbon must be bonded around by 4. Now, look at what I have. I now have HBr, which was extracted, but I then have sodium hydroxide. That is an acid, and that's a base. And that should automatically give us NaBr plus H2O. That is very, very important. All right, so that's our full structural. What did they say we should use again? Oh, structural formula, and that's it. Please understand organic reactions can be made easy if you just come back and follow this. Anywhere you see this, whole thing. Please understand, it's a trademark of Krazifizix. It makes it so easy. It has never failed once. Just go back, rewind it, and you will be done with organic reactions. So simple. All right. Anyway, this is Krazifizix, and mission accomplished for this particular video. Ooh, that's me there. All right, that's Bishop there, making math and science very easy. 0817442103 would be a phone call to the office where you can ask for our physical and online classes. You can also follow us on all social media platforms at Krazifizix. Download our study app where you can have school in your pocket. All of these explanations just right in your pocket. You can also get our definition cards, which makes it easy to have. That's a full textbook in just a little ring there. Just hold it and study on the go. All definitions and explanations, over 200 concepts explained. Have a beautiful day and God bless you. I'll catch you again in the next video. Goodbye.